Hello, I am Patrali Pradhan, Assistant Professor in Department of Computer Science and Engineering in Haldia Institute of Technology. Today I am going to discuss the topic on linked list, which is a one type of linear linked list, linear data structures. Other linear data structures are there. I have already discussed in my previous slides, previous PPTs. Today I am going to discuss about linked list. As the name says, list which is linked together. List means that is a collection of data elements, and those data elements will be linked together. And also, as we know, array is one linear data structure where we can store or we can say array is a collection of similar type of data elements. But there are certain differences between array and linked list. I will discuss further what are those differences. Now, first of all, I want to discuss that what is linked list and what are the features. Then we will go for the creation of the list and other operations. As we know, in data structure, for every data structure there are some defined operations we can perform. So for linked list also some defined operations we can perform. First of all, linked list is a non-sequential connection of data items. Here non-sequential means uh, means the data items will not be stored in the consecutive manner. As we know, in array data must be stored in the consecutive locations. Consecutive locations means, if suppose I am defined one integer array, so obviously integer data elements will be stored. And for integer, suppose it for one integer it takes 4 bytes. So obviously, if the base address or the first address of the array index, it means array index 0 is 1000, then obviously array index address of array index 1 will be 1004, means, and next will be 1008, in this way. So if we need to store 20 data elements, so 20 into 4, 40 bytes will be consecutive memory blocks. But sometimes it may happen that in our memory, internal memory, that consecutive 80 blocks are not present, but 80 bytes are present, but in the scattered manner. So in those cases we can create linked list. So that's why it is a dynamic data structure. Dynamic also means whatever memory will be available, that will though in those memories data items will be stored, and those allocations can have different addresses. So that's why this is a dynamic data structure. The data items in the linked list are not in consecutive memory. Already I have discussed that they may be anywhere, but accessing these data items is easier as each data item contains the address of the next data item. As already I told you that accessing to access the access element access the element any element in the list, we have to access from the beginning. So that's why this is linear data structure. And so here you can see head is basically a null pointer, which is the beginning of the list, and here suppose 1000, you can see that these are the different addresses, not the consecutive addresses. And these all these structures are called as the node in the linked list. And every node will have two sectors for data and the link. And the link of the last node uh, will be at the null. Next, so what are the general features of the linear data structure? First of all, sequential organization. Order preservation means to insert, to delete, certain kind of order we have to maintain. Fixed or dynamic size means, obviously already I've told you that like array is a static linear but static data structure, but linked list is the dynamic data structure. Efficient access. In array we can access any element, any element in constant time access, because if we provide the particular array index, then we can access that element directly. But in linked list we have to access from the beginning. Now, array versus linked list. Array in array, inserting or deleting an element at the end means, uh, every time whenever we are inserting data, that will be inserted at the end. And also delete is also, you can delete element from the end. Randomly accessing any element, we can access any element randomly using array index. Searching the list, static list, and wastage of memory. Why wastage of memory? As I told you, that suppose you have declared array with 20 size, means 20 elements maximum you can store. But in when you are doing your means for your purpose, suppose you need only 10 locations. So when you are declaring for the 20 elements, so it will provide you consecutive 80 bytes. But actually you need for the 10 elements means 20 bytes. So other 60 bytes will be wasted, because that will not be allocated to any other user. Linked lists are suitable for inserting an element, deleting element, obviously, and applications where sequential access is required. Already I have discussed that from the beginning you have to access the element, any element in the list. In situations where number of elements cannot be predicted beforehand, means in linked list we don't need to define any size. Whatever length, in whatever length we want to create the list, we can create. That's why this is a dynamic list, and obviously there will be no wastage of memory. Now, some extensive features, like it is a abstract data type. Abstract data type means the data type with some abstract methods, like linked list. Linked list is a linear data structure, okay, but for when we are saying about linked list, certain defined operations we can perform in the linked list, like stack. In stack, as we know, when we are saying about stack, so we know that two particular operations like push and pop we have to perform. So these are the declared method, but user can define that push and pop in their way. There is no definition, means specific definition in the system. So abstract data type That's why this is abstract data type. Means we can define insertion, deletion, or for any other operations in our own way. Element is stored in each node. Here, as I told you, that every structure is called as the node, and in each node has two parts: data part and link part. Link part is also node type, because this link is connecting to another node. So obviously this link is will be of this node type, and link of the last node will be null, and head is the pointer which will point the beginning node every time, and it is dynamic in nature. Now, what are the operations we can perform? Insertion, creation, insertion, deletion, searching, sorting, and merging. These are the general operations we can perform for any data structure. Now, first of all, we have to create a node, create a blank node. Node structure basically. Suppose this is one node structure, so for that case we have to define one structure, struct node in data, struct node starling. I have given here some pseudo code in C, because that is the general language, development language, general development programming language uh, for any data structure. So here, using struct keyword, I have defined one node structure which has two parts: data and struct node start link. Link is basically this node type pointer. Then I've taken another pointer head which is null initially. Then create the first node. So suppose means now we are going to create our list, means which will have first node. So here I have taken another pointer temp, and using temp I have allocated the memory block for the for storing the data and link part, means that storing the node. So that's why we have used malloc function here. As we know, in dynamic memory, when I've discussed the dynamic memory allocation, that time you know that what are the different allocation functions, or to free the memory, free is there. So calloc, malloc, these are the, or realloc, these are the functions through which we can create the memory allocation. So struct node star malloc, size of struct node, then temp link equals to null. At first this link will be null. Then head, at first head was null. So if head is null, then what you have to do, you have to take the data, means from user you are taking the data. Then temp data equals to n, means any through n you are inserting data. Then head equals to temp. So very easy, means just you have to remember this one. Means first you have to create a blank node, then just put your data item, and link will be null. Okay, and head pointer, that was initially null. Null means head was not pointing anywhere. Now after creating this node with the data, head will be pointed to the first node. Okay, so next we are uh, going to define other nodes. Means we want to create the nodes in for our own purpose. So first of all, we will take another pointer pt, and pt will point to this head. Then up to pt not equals to null, we will traverse the list. means up to this end point we will traverse. So at first only one node is there, so this loop will be executed once. Then we will take the data, and here must be pt, sorry, this is I have to correct this one, that pt data will be n and pt link will be uh, oh sorry, temp is our where the node, using temp actually we have created the blank node, so that's why temp data, temp data will be n, and pt link, now the pt is here, pt, suppose you have the first node, so pt is here and pt link will point to temp. Now insertion at the beginning. So already we have seen that how to create a node at the last position. Now we are going to create at the beginning. What will be the step? First create a node with data, then link of new node points to head node, then make new node as head node. So here struct node temp, then temp malloc already you know, then data temp data equals to n, temp link head temp data equals to n. Now as this is the this will be our first node, so suppose this is the list, and here this is our new node, and now this temp link will be head, this is our head. Now and head equals to, now when temp link equals to head means previously head was here, and uh, then temp is our new node, and which is containing suppose data 2, and temp link will point to that head, head is my current beginning node. Now after linking this node into this head node, this node will be your first node, so head will be traversed backward, and head will point to this node, means now this newly added node is your first node, so head equals to temp, this is basically temp node, and here, so head will point to this node. So obviously this node will be our beginning node, means we have inserted a node into the beginning of the list. Now insert at specific location. For this case, suppose this is our list which is containing two nodes, and we want to add the node in between these two nodes. Then what you have to do? Suppose your list is containing n nodes, so first of all what you have to do, that you have to take the location, in which location you want to put your new node. So first of all, as you know, pt is our head, pt is assigned as a head, then temp, using temp we are creating the creating new node, and then data element we have to insert, again we have to take the location, then temp data equals to n. Now we have to traverse the list up to that location minus 1 using this, suppose pt, because already we have taken pt is pointing head, so whenever we are traversing from the beginning itself we have to traverse, so up to the location minus 1 pt will be traversed, pt equals to pt link. Then after that what you have to do, Suppose now this is your temp. Okay, so and location -1 means this one. So you want to insert suppose second position, so pt will go to up to first position. So this is your first position. So now pt link, temp link means this is your temp link equals to pt link. Pt is pointing here, so pt link means this node. So temp link equals to pt link and pt link equals to temp. So this kind of connection you have to create, so automatically that connection will be lost when you are connecting these two links to that particular new node. So obviously the older connection will be lost and your new node will be inserted between these two nodes. See, now delete a node from beginning. Means from the suppose there is a list and from beginning position we want to delete. Now, so for that case, for what we have to do, that obviously beginning node is my head node. So when we are deleting that beginning node, head will be traversed to the next node. So see, struct node p star p equals to head, and at first p is another pointer which will point to head node itself. Then item equals to means we will collect the data item, because when we will free the allocation, that node data will be lost. So that's before losing that data, we will collect to that data into our data item. Then head equals to p link means head, now head will be pointed to the p link means the next node. Now free the p. After moving head into the next node, you have to free the allocation. See, delete from specific location. Now means suppose from anywhere from the list you are deleting any element. So again you here you have to specify the location. Then pointer you need, another pointer you need. First of all pt equals to head and temp is another pointer. Location you have to put location -1 or location -2. Here we are taking location minus until location -2, pt will be traverse. Then temp equals to pt link. Temp equals to pt pt link means temp, suppose temp is is our temporary pointer. So temp will point to this pt link means this node will be pointed by the temp pointer. Then temp data we have to take or you can display that data. Then pt link means if you want to delete this node, so this connection will be lost and this will connect to that node. So pt link equals to temp link means temp link means this node and pt link means this node. So now after deleting this node, obviously you have to connect the other two nodes. So that's why pt link equals to temp link and then free the temp. Temp is pointing this node, so you want to delete this node, so then you free this allocation. Now linked list has just here I have shown you that specific location deletion from specific location. So obviously you can can delete from end also. Just for from end, how to delete that, just you have to go, you have to free the allocation, and the last link pointer of the last node. After freeing the allocation, and the earlier node of the last node will be your last node, so the link part of that node will be null. So delete from end is very easy. Now I'm going to discuss certain categories of the linked list. First of all, double linked list. Double linked list is what? That double linked list means here, as till now we have seen that linked list, in single linked list, one node is containing one data part and another link part. But in double linked list, there will be two links and one data part, means three sectors will be there if in each node. Two links means one link will point to the previous node, and another link will point to the next node, which is you have shown, means you have seen that in the single link list. But in double link list, there will be two pointers. Here, see, this is a structure of the double linked list, means there are three sectors. In the middle there will be data. This is the previous pointer, which will point to the previous node, and the next pointer will point to the next node. So means every node will have two pointers, so the list will be look like this. And here, tail is optional. Tail you can take, or this is not mandatory that last node will be called as the will be pointed as the tail. But head is mandatory, because whenever we will traverse the list, we need the head pointer, because head will be pointed to the first node itself every time. And other operations will be like the single linked list. Just you have to point to extra pointer, you have to point through extra link, otherwise all the operations are same. I'm not discussing in the detail. Another variation is circular linked list. This is kind of structure where this is a single linked list, but the last pointer, as we have seen, that last link pointer will be at the null, but here last link pointer will point to the first node. So every time whenever you are creating the node, the link will not be null, link will point to the first node. So if suppose you are creating the first node, so link will be here, there will be the question in your mind, but link will be pointed to that node only. Again, when you are inserting another node, the link of that node will point to the first node in this way. So this is a circular linked list. I am not going to discuss in much detail, because there are certain applications and other things are there. Probably I will discuss in the other slides, other PPTs. In today's lecture, just I have discussed certain operations on linked list, and the differences between linked list and array, and what are the advantages in the linked list. So in the next lectures, we will discuss how to implement stack and queue data structure using linked list. So for now, thank you.